Welcome, everyone. My name is Raven Lee, and I am the Program and Enrollment Specialist here at the Data Incubator. We are a fellowship, scholarship, and placement company. We have promised you all an excellent info session that will be led by one of our instructors, Anna Hocevar. Anna will link a notebook in the chat that she'll be using during the demonstration. Please make sure you have access and can follow along. To start things off, I would like to give you a quick overview of our programs and everything that we offer. Then I'll hand over to Anna, who will jump in right to the live demonstration. And we will leave some time at the end for questions. Please be sure to place all of your questions in the Q&A section, and we'll answer them at the end of the presentation. As a reminder, our session is an hour long. So if we don't get to all of your questions today, please email us at admissions@the-data-incubator, and we'll be happy to help you. So what does the Data Incubator offer? The Data Incubator focuses on training people to become data scientists and data engineers. Why is that important? It's important because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a variety of industries, ranging from tech to finance, to retail, to healthcare, and many more. Every company has data and wants to use the data to drive value for them. What makes the Data Incubator different? So there are a lot of other data-focused programs out there. So I'm sure you're wondering what we do at the Data Incubator that's a bit different. What we found is when you look at training, there are two different types. One is fast-paced and efficient, and the other is slower and focuses on understanding and completion rates. University is one example where you'll receive a more detailed understanding. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. On-the-job training is usually very quick and efficient, but maybe you're not understanding what you're doing. We've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You walk out of the program knowing a lot about data science and data engineering, but most importantly, the real world business applications with a deeper understanding as you'll get from university. All of our instructors are PhD and master holders, and many of them have completed this program themselves. So they know how to provide that in-depth training that you are looking for. So our program offerings. So we are so excited to announce that our spring 2022 cohort will be offering 3 data-focused programs. We will be offering our successful full-time data science fellowship program and a more flexible version of that, our part-time data science fellowship program. We are also offering our new full-time data engineering program. So I want to take some time to review the similarities and offerings for all 3 of our programs. All of our programs are intense. They are built around hands-on data-focused curriculums. We offer both full-time and part-time programs, and both are packed with a lot of information and tools. They're thorough. Each week focuses on a different data tool or approach. In addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment, and so each program, students will work on many projects that focus on the data tools you are studying. Additionally, our programs are very collaborative. We want students to not only work with their colleagues and instructors, but to also have the opportunity to network and connect with our hiring partners. All of our programs are career focused. We have career coaches that help you succeed in your data-focused careers. You will not only learn how to present your best self by attending our career search workshops, but you will also have the opportunity to work with a #1 resume writing company to get you a polished resume and cover letter. Lastly, all of our programs are interactive. Each student in all of our programs are provided a Jupyter Hub server for the duration of the course. So students can follow along in lecture and see and edit raw code that's being run. Students will receive immediate feedback via our interactive grader. If you're interested in learning more about our data science or data analytics programs, please email admissions at the Data Incubator to be connected with an enrollment counselor. So this is our full-time data science program. The full-time data science program lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week in class and working on assignments. Here is an overview of our full-time curriculum broken down by week. And I know I'm going to go by this pretty quick. So if you would like this curriculum emailed to you, just email us at admissions at the dataincubator.com. So this is our part-time program. The part-time program lasts for 20 weeks with classes held on Mondays and Wednesdays from 7 p.m. Eastern Time to 9:30 p.m. Eastern Time. Expect to spend 10 hours per week working outside of class. Office hours are available each week. You will receive the same excellent curriculum and training as our full-time program, but at a slower pace. The sessions are live and instructor-led, so you are still able to interact with your instructor and ask questions. And then our last program is the full-time data engineering program that lasts for 8 weeks with classes held daily as well. So you can also expect to spend about 40 hours per week in class and working on assignments. Here is an overview of our full-time curriculum broken down by week. Again, if you would like this email to you, please email us for more detailed curriculum overview. So that's just a little bit about TDI and our programs. I will now pass off to Anna to lead you through our live data science demo. And I will come back at the end to help answer any questions.
Thank you so much. All right, let's get started. So I will also share my screen. So I'm Anna. I am one of the data instructors. And today I am going to give you like a short demo on how to build a simple natural language processing machine learning model. So what I mean by that exactly is that imagine we had the following problem. Hopefully you see my screen. So imagine that we were a company that is an internet provider, and we would like to improve our customer service. So when customers write to us, they either have a problem with their online account, let's say, or they have a problem with our service or equipment. So we can have messages like, I'm having trouble accessing my online account. Or we can have things like the router that was shipped to me is not working. So those are kind of two different categories of messages we might be receiving. And because we would like to process these efficiently, we need some way to have the service or equipment messages get sent to our tech team, and the account complaints to be sent to our accounts team. So what we would like to do is use machine learning to automatically classify these messages into these two categories. Yeah, so that's kind of what we would like. Just have some machine learning model that can say that message is in that class, that message is in that class. Okay. Now, in order to build such a machine learning model, we would need data with tons of customer messages. I don't have that data, but I will show you how to build a simple classifier like the one I just described, but on a different data set, right? So the tools and techniques we will use will be the same, but the classifier itself that we will build will be the following. Given some text, we will want to classify it into two classes, and the text that we will have will be classified into either, is the text talking about Python, the programming language, or is the text talking about Python, the animal? And I will also show you how to package a machine learning model like that into an interactive web app, like the one you see right here. This is a simple Streamlit app, more on that later. And I'll show the link to this app in the chat later as well, so you can feel free to visit this website. And as promised, it will be an app where I can put in some text. And I get a prediction of whether that text is about Python the language or Python the animal. This was classified to be about Python, the language, about the programming language. We also have something more about the model itself. So it's just part of the app that I pre-created for you. So I'll show you how to do all of this today. And let's get started sort of at the beginning. I have a Jupyter notebook here that I'll walk you through, but all of the code you can find in the repo that I posted in the chat. So what we want to do is build what would be called a word usage classifier. So basically a machine learning model that can take some text and classify it in a particular class. Just kind of for anyone who is here and hasn't heard of machine learning before, roughly speaking, machine learning is a collection of tools and techniques that allow us to put in some data and then find patterns on existing data in order to make predictions on the future data or unseen data, if you will. What we are going to be doing today is going to be what is called supervised machine learning. That means that I have some data, and in that data, I need to have sort of rows and columns, if you will, where every row is an observation in my data. In our case, our observations would be different examples of text. And we'll have to have some features of every observation. And in supervised machine learning, we have also a label. So every observation from my data has a label, has a target, basically what I'm trying to predict. So it means that in my data, I will have to have examples of text with the label. Is this text about Python, the programming language, or is this text about Python, the animal? Yeah, or whatever your class is, maybe. Yeah, if you had a different data set, your labels might be different. But still, you will always in supervised machine learning have your data matrix X and your label Y, so that you can train this machine learning model, this mapping between an observation with its features and what the label is. This machine learning model will learn this relationship so that then on some new data for which we don't know the label, but want to know it, we can apply our model and get predictions. So that's machine learning, supervised machine learning kind of in a nutshell. We'll be doing classification because our labels are classes. They're not numbers, but it's Python the language or Python the animal are our two classes. And we will be doing natural language processing. What that means is that we are using text. The data we have, it's not numbers. I just have some text, like I love coding in Python, or I have a wonderful snake at home. Yeah. So that's just text. So we need a way to convert that into numbers, as you'll see in a moment. But broadly speaking, whenever we are using human language, as in our data, we have to do some natural language processing. And today I'm going to show you a simple way to do that. I am going to gather my data from Reddit. So you can see more of that in the code that I posted in the repo. I'll go over this sort of briefly so we can focus on doing something with the data. But in Python, there is a library or package called pro that is just a very convenient way to fetch data from Reddit. And in Reddit, there are two subreddits. One is called Python and the other Ball Python, which is essentially going to be a place where I'm going to get a bunch of text relating to the two topics. Python stands for Python, the programming language, and Ball Python is the Python, the animal topic. So I'll just grab a bunch of text from there, and that will be the data on which I'm going to train my model. So we do that. Here, there's some code that I've already pre-written. And you, again, have this code in the repo I posted, so feel free to use it if you would like. All that this does is it checks if I have this file that contains my secrets, because you do have to register with Reddit to get some credentials to be able to fetch the data. If you look at the documentation, it's very self-explanatory. And if I have that, I can create what I'll call this Reddit object that will allow me to use this API from Reddit and fetch the data. So I'll do that. And then I've also written a function here that, given either Python or Ball Python, meaning do I want Python the animal text, or am I fetching the Python the programming language text? this function then goes and checks in the subreddit of that word, but then iterates over that subreddit's hottest, we're going to say 100 topics, basically. And then from that, we are going to fetch the comments. Yeah. And then we get top level comments from that, and we just package them into a Python list. So all that this does is, if I call that function with, let's say, Python, I'm going to get a bunch of examples of text when humans write English and are talking about Python, the programming language. And that will be my training data. I'll also call it with ball Python, which refers to Python, the animal. Have another function here that will do exactly that. It will call this function that I'm calling get comments. Yeah, I'll just call that function either for Python, the animal, or Python, the programming language. The only extra thing that this function has is, if I already have this data stored in a file, which would suggest I've already got it from Reddit at some point and saved it to a file, so I don't have to do this every time I might need this data. Well, in that case, I'm just fetching that data from that file instead of fetching it from Reddit again. That's all that this does. So what that means is that now we can actually get the data, and that means that I am going to use this fetch corpus. And if I show you what that looks like, if we call this fetch corpus on ball Python, that's the subreddit talking about Python, the animal, it gives me a list of comments, basically. So something like feeding weight, length, cages links seem to not be loading. I should prefer feeding it. Should I try feeding? People are talking about Python, the animals, that is. So I'm going to call this animal comment. Yeah. And then I'm also going to make a list of comments about language, the Python, the language, that is. So let's make another list, which will be calling the same function fetch corpus, which is going to be, oops, I'm going to call it with Python. That will get people's comments talking about Python, the programming language. So now that I have both of those are two just Python lists. I am going to put them together in what I'll call corpus. This is commonly a word used with when we're talking about natural language processing. So I am going to put the animal comments together with language comments. So that's my corpus. We also need the labels though. So I have to create labels for every row. So the first, however long this list is, should say animal. Yeah, oops, I need the length of that. Yeah, and after that, the rest of my list will be language. Yeah, so times then the length of this, how many observations we have there. Good. So this is my data. Good. I have my corpus. I have my labels. We are ready to continue. Now, my corpus, which will be the data I will train on, is text. So we have to convert this into numbers in some way, because that's what goes into a machine learning model. We are going to use what's called the bag of words approach. This is a very simple approach where you take some text and you create basically like a tally of, for every word, how many times it appears. And appears 0 times in here. Brown appears once. Fox appears once. So you're doing like a counting of words. That's why it's called a bag of words. And I will, of course, be using Python's scikit-learn library, the star of when we're doing machine learning in Python. And if I import from feature, my autocomplete will help me here, extraction, from text, I am going to import what is called the count vectorizer. And count vectorizer does exactly what we want here. So if I make an instance of count vectorizer object and I call fit transform, this is, if you already know a bit about scikit-learn, you know how this works, what the fit transform actually takes some text and transforms it. So if I say the quick brown fox, and let's say I have brown fox is happy. If I do that, you will see I get a sparse matrix, but I can actually see what's in it, if I convert it to dense, just have to be careful here that this matrix not too large when you do that. And if I check on this CV, get feature names, that shows me the first column is counting how many times brown appears in the first observation. Aha, once. And in the second one, aha, once. That's what this one is for. This, for example, stands for happy, the third column. Happy does not appear in here, but it appears once in here. So count vectorizer will be very useful for us. That's what we'll use to transform our data before we plug it into a classifier. And that's what we'll do next. We need to now train our word usage classifier. We will use the naive Bayes algorithm. I won't go into details here. Feel free to check it out. There's a lots of tutorials on naive Bayes. It's a very simple model, but it works quite well with natural language processing models. So what we are going to do, let's do this very proper. So as you may know, the proper thing to do is that I first split my data into what I'm going to train on and leave out a bit of the data as my test set. And in scikit-learn, that's very convenient to do. If you import the model selection, it has a train test split function that does that for you. So you can just say train test split, plug in your data. Our data is corpus is our data matrix. Labels is how we called the animal, language labels. And I can specify how big I want my test size to be. So I can say I'm going to do 20% of my data in my test set. Yeah. And I can set the random state if I want. Maybe let's omit that at this moment. What that returns is the training matrix, the test matrix. It splits basically 80% of your data is in your train. 20%, because that's what I asked for, is going to be in the test. Okay, so when I run this now, I have my training and test data. And then now let's build our pipeline for the model. So I am going to be using, as I said, naive Bayes. So I should, from here, import multinomial naive Bayes. I also will import a pipeline because I am going to build a scikit-learn pipeline for my model, because I have first a transformer, which is this count vectorizer I showed you. Yeah. And then I have the naive Bayes. So if we construct our pipeline now, I'm going to call it pipe. We could call it our model. My pipeline has two steps. Remember, what I have to do with my corpus first is I need to do a count vectorizer. And the next step in my pipeline will be my naive Bayes. Okay. So in a pipeline, I pass in a list of Python tuples. Every step is a step in the pipeline. So what happens with my data as it gets trained and then as I make predictions. And the first thing I do is I have to use this count vectorizer I mentioned here. We first have to do this, and then a matrix like this with all of the data. Of course, here I just made a little example, gets passed then into naive Bayes after that. And that exactly is what pipelines do for us. Now, they allow us to kind of sequentially process the data like this. So as I have a pipe like this, now I need to train the model. And as I call fit on that, on our training data, of course. So remember here, I took our corpus, which was our everything we fetched from Reddit with our labels. Now I have that split into X-train and X-test. That just means a chunk of the data landed in the train and a smaller chunk is in the test. So I will use, of course, the train here because that's the data I'm fitting on or learning on. So I want and Y train, that is the data I am going to train on. And what happens when I do this on a pipeline is that here under the hood, what gets called is on this first transformer, fit transform gets called. So it's like this is that. And then on this, under the hood, that's what pipeline does for you, which is why I plugged it in there because it's so easy. It's going to do everything for me. It's going to call fit transform on transform on this data. And then the data that returns, so X, let's say transformed, that then gets plugged into whatever in our case is already the last step. I could have had more transformers along the way, but here, yeah, I have my multinomial naive Bayes after that. And the data that gets plugged into here and then fitted is the transformed data. So this one, okay, that's what a pipeline does for you. Okay, so I'm going to call this, but I just need to say this and it does all of that for me. Ta-da, and I'm done. It takes not so long because I didn't fetch that much data from Reddit. More would be even better. Now what I can do is, of course, compute how well the model does, which means I can say pipe dot score. That gives me, in our case, accuracy, because our model is a classifier. So that in scikit-learn will give me, if I plug this data in, well, that gives me the accuracy on my training data. But really what I care about is how well does the model do on the data that it was not trained on, but on the data that I'm going to test it on. So this one. Yeah, and it happens to look like it's doing very well as well. I want to warn you here, this is a very simple model. There's the world of natural language processing and building machine learnings with that is very, very big. So we are really scratching the surface here with the bag of words model, meaning the count vectorizer being the only thing we did with the text to transform it into a data matrix that's numeric. There's a lot more sophisticated things you can do here. So on this particular data set, it looks like we're doing quite well. This is a great, right? I have test accuracy of 69%, but still, this is actually a simple model. Yeah. That said, let's test it a bit. So I wrote a couple test sentences here. I want to learn Python. My pet Python ate the mouse and so forth. Let's use the model on it just to see how it does. So if we say pipe is the name of our model, predict, that makes predictions. So I can just plug in test sentences here and see what we get. So for the first one, it says that's about Python the language. This one, it says it's about Python the animal. This one says it's about Python the language, so not bad. Of course, it makes some mistakes. There's a couple here that it gets wrong, certainly. And if we put in some text that was more complicated or not even have to do anything with either Python the animal or Python the language, it would just pick one of the two. So it's not perfect model, but it's kind of not bad either from what you can see here. Yeah. So this is our model. Good. Now, what I am going to do, because I'm looking ahead at this app we want to build, where I want to use the model I just trained, where the user puts in some text and it spits out this prediction. So how can I do that? How can I use this model in there? In order to do that, what I'm going to do is I'm going to save the trained model. Yeah, pipe is the model, the scikit-learn model on which I can call predict that's already been trained. And I am going to save it. You can either use pickle, if you're familiar with the pickle library. I'm going to use joblib here, and I will just dump that into a file that I'm going to call classifier joblib. Yeah. And given the time, I have a little bit more here, and you will see the results of this code in our app. So that's what I was showing you here at the bottom, where I can do some analysis where I check, so what are the words that are heavily present and help the model indicate that we're talking about Python the language versus Python the animal. We can visualize those results in a word cloud like this. All of the code here, again, is also in the repo that I linked. So I think I'll move on to talking about how to make the app itself, because then you can just plug in that code into the app. So let's maybe from here, now that we have the trained model and we saved it, let's make an app. Now, the way we can do that is, there's a lot to say here. So what I'm going to do a little bit of right now is kind of like what they do in the cooking shows, where they show you many things to do, and then they put the raw lasagna in the oven, and then they say, and cook it for an hour, and then 2 seconds later, they pull it out and it's finished and it's better than what they had before. I'll do a little bit of that just because of the time we have, but I'll show you the code. And again, you have the entire code in the repo. There's different ways to create an app that when you visit it, it runs some Python code in the background. So in order to get this prediction, it has to use that pipe, that model we trained. So it has to run some Python in the background, but this is a website that you can visit. I'll give you the link. So there's different ways to achieve this. One of the simplest, I would say, ways is using a Streamlit app. And that's what we'll do. You want to install Streamlit on your computer or the computer you'll be using, and then just create a simple empty script called whatever you want to call it, .py. And then what you need to do is a couple things. So the first thing you want to start with is you want to import Streamlit, like this, and it's customary to import it as st. And then the next thing I'm going to do is, because I know we're going to need joblib in order to unpack this, from the way we unpack it is we take the file and we say load. So I'm going to need this library as well. And then I'll create my app. And the way you do that in Streamlit is you just say, I make my app function. In here, we're going to write what do we want in our app. And then you just have to basically, as any other Python script, I will shield it with the if dunder name equals dunder main. And when that script is therefore run as a standalone script, I will call the app function. So let's tell it, what do I want to happen in app? Let's imagine I'm gonna write a title in there. So I say Streamlit, so st.title. That makes a title. So let's call simple app here. Okay, let's stop there. That will be just a website where it will simply say simple app here. The way that I can check what that will be like, this is not going to be deployed yet where the whole world can access it, but I will instead just locally start up this app. And the way you do that is if you've installed Streamlit, you simply say, let's say that I am in the folder in which, or directory in which this script is. I simply say Streamlit run this script, which is called appdemo.py. When I do this, it starts up my app locally. It will tell me that it will be at localhost at port 8501, and it opens that up for you. So notice I'm here at localhost 8501, and there's our website. It says simple app here. Wonderful. Let's add to that. Now, one thing I can add is actually a sidebar. So I can say sidebar markdown. And if I do that, I can here say, let's say this is a sidebar. And then if I save this, I just saved what I changed here, and then reload this page, you'll see that my app, I see the changed app. So this is a sidebar. So you can put stuff here, you can put stuff here on your website, whatever you like. And you can add images, you can add plots, you can add pandas, data frames, you can add any Python objects to your web app, whatever you want. For the sake of time, the one thing I will show you is how you can get the user to be able to put in some text. So let's do that. What you need to do is do something like streamlit.text input. If you do that, you can say here, please put your text input here. Input here, and let's, when nobody has put anything in yet, let's have the default be an empty string there. You could put something that will be grayed out in here. Yeah, if we at the beginning, when you have it, it's blank in my case. If I reload this page, you'll see it's blank, but I could have here added something that's sort of like a template, where it could say example text in here or whatever you'd like. I left it blank, which means I'll leave it blank here. And let's call this text. Now, means, so now that I have this, so if I save it and we look at what we've done, that means I have that here now. And whatever I write in here and click enter, something, and I click enter, now text equals that. So equals the something string, but I now have to do something with this text. And this is where I'm going to say, if the user provided some text, so if I have something in there and somebody clicked enter, then, ooh, we need to load our model. So let me load, yeah, I'm using this load now, and I'm going to load, I actually have that in the models folder. So I have to say here, models, classifier. I believe that's what I called it. And now I can say prediction is when I call my pipe with predict and pass in this text that the person gave us, right? Now I have to be careful. This should be a list of text, so I have to wrap it in like this. Yeah, and then simply if all we write here is st.write and then some Python object, let's say prediction. Yeah, let's see what that is. Now this is actually going to be an array of predictions. It's expecting that this has many examples of text, so it gives us many predictions. I'll index into it so that we just get the single prediction that we're making, because we're using just a single text as the input that the person can give us. So that's what you see here. Let's say that we put in, I love coding in Python, enter, I get, it's not called models classifier. I think this should be a backslash because it's in file, in folder models, but that's the name of it. So let's redo that. We hit an error, right? It was complaining, I can't find this because I didn't spell the location of the model correctly. I love coding in Python. Yeah. Ta-da, it's about language. Now, of course, I can make this into a nicer output. I can also add the plots that I showed you right here. And that is exactly what you can see. If you visit the repo that I linked, and let me link it again in the chat. Let me just make sure that goes to everybody. So this is the repo. This is the actual app where it is deployed. We haven't done that yet, right? When you are done with your app and it looks the way you'd like it to when you run it locally, the easiest way, or one of the easiest ways to deploy your app so that it actually goes on the World Wide Web, it's not just running locally, is if you make a GitHub repo, you push all your code there, and that's what you see here. For example, app.py, that's the script that I was kind of showing you the beginning of, but this is my baked lasagna now, where it has a lot more in there. There's a couple more functions, but you've seen this. Title, we're creating a sidebar with some links. I can input the text, then I load my pipe. And of course, I'm adding a couple more things here so that my actual app also has a picture here, for example. You can see that right there in the sidebar. I added some links here to the project, to scikit-learn, Streamlit. But nothing that spectacular out of what I've shown you. And when you have all of this done, if you just push it into a GitHub repo, then it's pretty simple to, for example, use Heroku to actually deploy your app. So if you go to Heroku, Heroku, that's how it's spelled. You can for free have a couple of apps that are not bigger than, I think, 300 megs or something like that. So this didn't cost me anything to have this app up. Yeah, of course, if it's for free, it's limited to what exactly you can do. But in doing that, when you have a GitHub repo, is also pretty simple. You just say, I want to make a new Heroku app. You say from GitHub, link it to your GitHub account, pick the name of the repo, and just say, yep, deploy. And pretty much it can work. The only thing you will need in order for that to work is this setup proc file and the requirements. And I am sharing this here with you, and feel free to use it and copy this. If you're making a Streamlit app on Heroku, all that needs to be there is this, just literally copy it. And proc file also, this tells Heroku to run this app as a Streamlit app. So in this, you just take exactly this. And in requirements, you just need to put in all of the libraries that your app needs. So in this case, we used scikit-learn and we used joblib and matplotlib because I plotted things. So you basically just have to put all the requirements in there, and that should be sort of it. This is a public repo here. Feel free to fork off of it or use it to whatever you may need. I'm looking at the time, and I think I'm basically almost out of time here. And I think I covered pretty much everything I wanted to. If you are curious how these plots that appeared here below in the actual deployed app, when I said, I love my snake pet. So if I have a couple more stuff here that I plot, and this is a word cloud that was computed, again, all of the code is in here. So you can find that in the app. And that should hopefully help. And also, I should add more. In the source is actually the source code. So everything that was in the notebook I was sharing is also in this train model script. All the functions, the get comments functions from Reddit that I mentioned, the fetch corpus, everything is in here if you would like to use that. So feel free to play around. I think I'm going to stop here. I don't want to go too long. There's so much more to say, but I'll pass it back to Raveen.
Thank you. And I'm pretty sure our participants really enjoyed that. I could tell by the questions that they're really engaged. And we do have a few questions in the Q&A box for you, Anna, but we can save those until the end. So I'll go ahead and share my screen here. All right, so this is where we left off last time. So I'll move right along to our fellows versus scholars. So many of you have asked if we offer scholarships to any of our programs, and the answer is yes, we do. So we admit two types of students into our data science and data engineering programs. Fellows are offered tuition-free scholarships to our full-time program. We offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our program, and we are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network and may maintain their current employment. Scholars still have access to the same curriculum, resources, and tools as our fellow students. Full tuition scholarships are not offered for the part-time program. All right, so next we're going to get into just our employment rates. So a big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts, but also get placed in that field. Our engineering program is brand new, so we don't have any data yet. But for our data science fellowship program, 97% of our students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers. We're very proud of those, and we have worked very hard for them. That's part of the challenge, not only learning content, but being able to transition into a data science or engineering role. That's really where our program stands out because we help you do both. So where are our graduates now? And where are they working? Like, what are they doing? So again, data is not available for our engineering program just yet, but for our data science fellowship, this would give you an idea. Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. Some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are some of the roles that we've placed in the past. I know we mentioned we don't have data for our data engineering program yet, but you'll see we have placed students in data engineering roles in the past. Many of our current hiring partners are looking for data engineers, and the demand for this role has grown 40% over the year. So our hiring partners. So here's a short list of some of our data science fellowship hiring partners. As I mentioned earlier, many of these companies are also hiring for data engineering roles as well. But we are also focused on building a separate network of hiring partners dedicated solely to our data engineering program. So next is about our financial assistance. So many of you were asking about our financial options, if we offer assistance, and the answer is also yes, we do. In addition to our scholarships, we have partnered with Leap to provide an income sharing agreement, and it's great. You can participate in our program with just a deposit down, and you won't be required to make any payment until you graduated and you are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 options. The first one is a deferred repayment option where you will make no payments during the program and for 3 months after the program. The second option is an interest-only repayment. So you'll make small interest-only payments during the program and for 3 months after, then full payments. And the third one is immediate repayment. So begin making full payments 1 month after the program begins. 36 months or 60-month terms are available. So that'll be your option. Lastly, for many of our part-time programs, many companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and be able to apply to your job during the day. If this is something that you think your company would be interested in, or you would like to present to them, we do have a letter that we can provide you that will help you lay out the program and all the benefits to attending. So these are just some important dates, things that you need to mark your calendar for. So where are we right now? Well, we do run multiple cohorts a year, and our winter cohort is starting in January 2022. But the application for our spring cohort is open now. So our spring cohort will run from April 4th for both full-time and part-time. It will end May 27th for our full-time program and end August 19th for the part-time program. So as I mentioned earlier, the full-time cohorts are 8 weeks long and the part-time cohorts are 20 weeks long. So some specifics just about our application. We ask that you submit your application by February 11th for the regular admissions deadline. You'll also have 72 hours to complete the coding challenge from the time you open it. And the challenge deadline is February 14th. So it will help to start on that application and coding challenge sooner or later because the deadline will be February 14th for the coding challenge, regardless of when you open the challenge. So you cannot complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge as soon as possible to avoid any technical issues. We are unable to reopen the application or challenge after the deadline. So just to reiterate those deadlines, February 11th for the application and February 14th for the coding challenge. If you're interested in applying to our program, which I hope you are, you can go to the dataincubator.com/apply to submit your applications. If you have any questions about your specific situation, this presentation, or going through our application process, please reach out to us at admissions@thedataincubator.com and we'd be happy to answer any of your questions. So we'll make sure that we share our email address in the chat box. But you've probably received several emails by now from us. So if you have any questions, just feel free to reply to those emails. So I also want to let you know about our spring special that we have going on for our Data Essentials course. So if you are interested in taking Data Essentials, we have a special going on. So you're able to take that course for only $1,000 when you register by March 7th, 2022. So we have a few minutes left before our info session is over. And I do want to open the Q&A section to any questions. So if you haven't had a chance yet and you do have questions, feel free to share your questions in the Q&A box. I'll stop sharing here and open that box up. So I see that we do have a couple of questions for Anna. And you've probably answered some before they asked while doing your live data session. But for, I guess if you see, yeah, some of the ones you could go ahead and just answer whichever ones that you
Thank you.
No problem.
I was trying to also type the questions right now as you were going through the rest of the slides, but I don't think I got to everything. So I see one about why the testing and training and what is X and Y. So X usually always refers to the data matrix where you have your observations and different features, and Y stands for the label or target vector. So that's where the label of every observation is. In our case, animal, language, that's in the Y vector. And then we split that into training and testing so that we try not to overfit the model. What that means is that you want to have a separate part of the data on which the model gets to learn and a very separate part of the data on which you actually test it. It's a bit like learning for a test, but then if you test yourself on the thing you already learned on, you could have just memorized that. You don't really understand what the right answer is. It's a little bit like that. You want to have a separate test set and separately the one that it learns on. So that's why the split. I saw a couple of questions on why the pipeline. So why should we use a pipeline? You could process your data outside of scikit-learn, maybe with pandas or a different tool, and just use the final predictor from scikit-learn. But that gets a bit clunky, especially if your whole model consists of many different transformers. So things you do with your data before you plug it into what makes predictions actually, which is called a predictor in scikit-learn. For example, imagine we had data with lots of missing values where we want to fill in the missing values, then we want to create new features out of that, then we want to maybe do something, scale the data. When you have many parts in that processing, pre-processing, it's much more convenient to use a pipeline because it's less prone to error. And also because the pipeline just allows you to say .fit and fits it, predict makes predictions. In that predict, when you call predict on a pipeline, it goes, the data that you're trying to make predictions on goes through all of the steps of the transformations that are in the pipeline. So it kind of just does so much for you and is much less prone to error compared to if you did it by hand. Do I get to keep going? I see a couple more.
Yeah, we have a few minutes. So
okay.
Yeah, you can keep going.
But if you have others you want to answer too, I see one about if we have a sentence that talks about both, yeah, our model gets to pick one. So if the model is about something completely different or about both, it will pick what it thinks it's the closest to. So that's where we could have a wrong prediction, of course. You don't have to use Heroku. You can just locally have the app running like I did there, but then only I can use it on this computer that's locally running the app. If you actually want to deploy it so that it has a URL that is on the World Wide Web where anyone can access it, you need to deploy it. Heroku is not the only way to do that, but it's a very easy, fast way to do it for small apps like this.
So I see a question. What is the fellowship application deadline for the summer cohort? So our summer program will begin on June 27th. The application is going to open up on March 7th. The early admissions deadline for the summer application right now is March 25th, and that regular deadline is April 15th. Okay, what about non-US participants who don't have a work permit? So you are able to attend the program from anywhere you are. We are all online right now. We do have one in-person session if you're interested, but you can participate from anywhere you are. So you would definitely have to consult with an immigration attorney if you're interested in like moving to the United States afterwards to work. But as far as just participating in the fellowship, you are able to attend. I'll go ahead and skip to this question. Are your hiring partners all in the US? So we do focus on placements within the United States. We may have some companies who have like a position or two that's like in Canada or not in the United States, but all of our placement focus is in the United States. Keep in mind that most of the companies are also open and have a lot of remote positions available. So if you're not interested in moving and you want to stay where you are, you will have the opportunity to interview for remote positions. And we have a few more minutes here to answer.
Then I think I see a couple more for me if we have time. There's a question on what's the difference between fit and fit transform. When you have a transformer, fit method fits the transformer, learns something about the data that it needs to learn to make transformations. Transform alone then actually does that transformation, takes the data and gives you the transformed matrix. In our case, went from text to number of times each word appears in every observation. And fit underscore transform is just fit followed by transform. So just both together, basically. And then I see another one. Are the test set and training set mutually exclusive? They have to not overlap in any way, shape, or form. Yes, they should be completely separate. So the test should be chunked off from your data, put into a drawer, never to be seen, and have anything to do with the training. And the rest that you get to keep, you do whatever you want with it. And then when you're done with the final model, you test it on that test set that was kind of saved very carefully away.
So we had really great questions today. Like, I really appreciate you all participating, because if you don't participate, then it doesn't make it as great as it was today. We are coming to the end of our time here, but I do want to make sure that we are able to answer all of your questions. So if you were unable to put your question in the Q&A box today, please feel free to email admissions. Again, our email address is admissions@thedataincubator.com. Oh, I see another question here. I think it said, where should I apply? 1 second, let me get the question. Where should you apply for fellowship programs? So you'll just go to our website. The application you can find on the dataincubator.com. So go to our website. You're going to find all of the information if you're interested in our data essentials, data science, or data engineering program. And I know it was mentioned that the slides will be sent to you all. So for all questions related to the slides, you will receive those slides later. And like I said, if any other questions, reach out to admissions. You're also able to schedule a one-on-one session with enrollment counselors if you have like anything else that you would like to talk about. And that's going to end our session. We have about 3 minutes before we end. We're going to end it here. And I'm looking forward to seeing an application from all of you all. And have a great day.
Bye, everyone.
Bye.